Hey, what's up everyone? Let's get straight into this next video. It's going to be on multiple covalent bonds. So what we've talked about so far is the idea of atoms joining together with each other to form a bond where they share a pair of electrons. Now, what we've got here is we've got a classic valence electron or electron configuration diagram. So let's just put that on top of oxygen. So we've got an oxygen atom on the left here. So here we go. Excuse me. So now we know that oxygen has 8 electrons. So let's fill them in. 1, 2, 3, 4, 5, 6, 7, 8, right? So we can see that oxygen has 2 available spaces to fill electrons, right? It's not quite happy. It's got 6 electrons in the outer shell. 1, 2, 3, 4, 5, 6. So if you had to draw oxygen just in terms of the outer shell, it would look like this. 1, 2, 3, 4, and then we've got 5 and 6. Okay, so let's take another oxygen atom. And let's say, okay, we got a same oxygen atom, same configuration, exactly the same. And this time we've got the electrons. Let's just draw them in a slightly different way. Sorry, that's incorrect. There's one missing there. We've got an open space. Whoopsie. Let's draw a nice open space there. Open space and fill that electron in. And this is the outer shell, which gives me 6, right? Okay, now if I drew it like this, 1, 2, and then 3, 4, and then 5. Actually, let's do it like this. Represent those electrons with crosses. 5. Actually, let's just do it like this. 5, 6. 1, 2, 3, 4, 5, 6. What you can see here is if these 2 oxygen atoms were to come together, and we know that oxygen exists in the atmosphere as O2, it's a diatomic molecule. So here's one atom and another atom of oxygen coming together. We can get those 2 there. We can already see our first covalent bond. If you sort of highlight this in red, or let's get the highlighter out, why not? So you can see here, that's the first covalent bond. But you can also start to imagine where another one might occur. And that's quite right. That over here there'll be another covalent bond. Remember, covalent bonds when they share electrons. So to draw this in a better way, you can draw those 2 oxygen. I'm drawing the left hand one now, and then I'm going to draw the right hand one over here. So we got 1, 2, 3, 4. Then this electron is going to shift all the way around to this side. It's going to pair up with this one. Let's pair those 2 like that. Those 2 are already there. Pair and pair, and then we've got the other oxygen atom with its electrons like this. Now this kind of looks a bit wonky. I mean, how would you be able to sort of structurally balance this out? Well, what you could do then is take the oxygen, put these ones on the bottom, put these ones, leave these ones on top. Then you have two pairs of paired electrons, if that makes sense. 1 and then 2, and then you've got the other oxygen atom, and then we can just go 1, 2, 3, 4. So you can see here that we've got 2 pairs, okay? And remember that if we had to represent this in another diagram, remember a line represents a pair of shared electrons. So in this case, there would be a double line. In other words, a double bond. And this is where double bonds come from. Okay, so this is an example of multiple covalent bonds with the molecule oxygen. Okay, excellent. Let's see if you guys can do one by yourselves. So let's just go, whoa, we're into chromatography here, hectic. Let's just take out this stuff now that you know what it's about. And let's give you another example. So let's give you, for example, let me think about it. How about, oh, let me just have a look here. I'm just looking through my notes. So we've got, okay, we've got oxygen. What about nitrogen? Okay, what about if you take 2 atoms of nitrogen. Okay, take these, see if you can figure it out, pause the video, and I will come back and give you the answer. Okay, so let's have a go at this one. Just a little quick note on the oxygen. I just read up a little bit about it. So we've got this double shared set of electrons like this in the middle. That would be the sort of double bond like that, if you know what I mean. But the other 2 electrons I drew like this, okay, and like that in the previous example. In fact, what actually happens and what they look like, we're going to do this in another chapter where we talk about the shapes of molecules and stuff like that, but they would actually look like this, okay, which makes it even more stable if you just put them in this sort of arrangement like that. So that's just something to be aware of. Okay, now for this example, I am going to show you a quicker way of doing this. Okay, so if you pull up your periodic table, which I'm just going to quickly go grab. So here's my periodic table. Let's just grab a little screenshot of this bad boy. I'm screenshotting and I've done it, and look at that. It's just quick and easy. Not that quick and easy. Come on, pay. Oh yeah, I've done 2. Look at me. All right, so you guys know how to do this, right? So we can tell how many valence electrons there are. Valence meaning that it's in the outer shell. So we've got 1 in this group, 2 in this group, got 3 in this group, then 4 in this group, 5 in this group, 6 in this group. So this is how many electrons are in the outermost shell. So we don't actually have to go ahead and draw that whole electron configuration, because we know nitrogen has 6 electrons in its outer shell. Beautiful. I get that from my period. Not 6, 5. What am I saying? 5. So we got 1, 2, 3, 4, 5, and this let's just draw it differently. 1, 2, 3, 4, 5. Okay, so how would these 2 interact with each other? How many covalent bonds? Remember, we're talking about multiple covalent bonds, so you can just kind of sort of figure this out. Just put them close to each other, and you can sort of see what's going to happen here. All right, we've formed 1 there. Then that one's going to join with that one. What am I talking about? I'm talking about these 2. And then that one's going to join with that one. And so we're going to form this idea of a triple bond. Okay, and then we're going to have those. I think they're just going to hang out like that. Okay, so it would look like this, triple bonds. Now there's incredible amounts of energy in each of these bonds, and to break that or overcome that force of attraction between these. Remember, with the covalent bond, it's the idea that the nucleus of this nitrogen atom is positive and these electrons are negative, and it's the strong attraction between these 2 components of an atom or a molecule is what gives the molecule the strength, or the bond the strength. So if you've got triple of that, it means it's an incredibly strong bond. Okay, it's an incredibly strong one. So this would be a triple bond. Beautiful, guys. I think you get the idea. I hope it's been super helpful, and see you next time.